Hello everyone, today I'm going to introduce you the new E-CAT configuration tool. The configuration tool is a software tool designed for connecting EtherCAT devices. With the tool, you can connect a device, monitor their status, and configure various connection and device settings. You can start the configuration tool from the control panel. The tool provides many functions. Today, I will use 4 scenarios to demo its main features. The first scenario is to use the tool to connect and control EtherCAT devices. The first step is to connect to an E-CAT MainDevice. What is an E-CAT MainDevice? Each E-CAT component instance has a main device. The main device controls the subdevices connected to it. Let's click the OK button to connect to the main device. Once connected, we need to create a project to save all the settings. Every time you use the configuration tool, you will be asked to create a project first. The first thing you see is the connection settings page. This page has 3 sections: E-CAT settings, access settings, and device settings. In the EtherCAT settings section, you can configure various properties of the connection. For example, the cycle time, which means the frequency of data transmit between the main device and subdevice, and other properties like restart main device automatically and use DC or not. The second section is the access settings. These settings define the data to be transferred between the main device and the access. For example, if you select the supported access mode to be position and velocity, position and velocity data will be transferred between the main device and subdevices. You can also check the other options here to transfer more data. One thing to know that is not all access support transmission of all this data. You need to check their ESI file. You can use our ESI import tool to see what they support, and you also need to enable related data transmission for the device in the ESI import tool. The last section is the devices settings. You can configure required access and IOs count. This is for you to create simulated devices. For a demo, I use the default connection settings and click connect. You can see that 1 access and 3 IO devices are connected. Let's first check the access. There are 2 tabs in the access view. First is the IO tab, next is the SDO tab. In the IO tab, you can see 32 input signals and 32 output signals. You can use these rectangles to see the IO status of the access, and you can also write output by clicking the box. The next tab is SDO tab. You can see that there is an object dictionary for the access. The object dictionary contains parameters that you can set or read from the access. And these parameters are loaded from the ESI database. The configuration tool uses the identification information like vendor ID, product code, revision number of the device to get the ESI data of the device and load the dictionary items and show it on UI. Since the device is connected, you can see its actual parameter value here. You can search for a specific parameter. For example, I can search for 6060. For example, I can search for max torque, and you can see that the current value is 5000, and I can give it another value like 4000. You can also add these parameters to the initialization commands. The initialization commands will be executed when the EtherCAT connection is established. So you can make sure that every time you create the connection, the max torque value will be set to 4000. If you already know the index and sub-index of a parameter, you can also enter here and to set its value like 6060. Okay. Next, we see the I/O device. For example, EL2004. You can see its I/O data. This device does not have any input, but have 4 bits output. You can view the values and write the values here. And this device does not have object dictionary for you to configure its parameter. And the next device is EL1014. It has 4 bits input, and you can read the value from the tool. There are some additional functions you can find from the right-click menu. For example, if you right-click on the access, you can use the FOE function to upload file from the device or download file to the device. And you can also request the device to a specific EtherCAT state. When a SubDevice is connected, it usually goes from init state to pre-OP state, then save OP, then the OP state. Sometimes you need to switch to another state to send some specific SDO command, like switch to the pre-OP state. And you can see that the icon color of Xeon Denki becomes purple. It means that it's not in OP state. Okay, when the device is not in OP state, the icon color will become purple. After verifying all the device works properly, you can save the project, and all the connection data will be saved. Okay, and next time you can open the project to reconnect. For example, I can disconnect the EtherCAT connection. Okay, and close the tool, reopen it. And open the project I just saved, test3. The project contains all the connection settings you used before and all the device you connected before. One thing could happen is that the device connected could be changed. For example, you may add additional access or change the order of the I/O devices. The configuration tool will detect this change and do a matching between your saved devices and the found devices. To demo this scenario, I will switch the sequence between the first and second I/O device in the project. So when I connect again to the I/O devices, you will find that the sequence is different from the project configuration and the real devices. To do it, I first set the index of the first device to maybe 9, and the second device set to 0 to make it the first device, and the first device to set to 1, make it the second device. You can see that a device matching dialog is pop up. You can see a device matching dialog pop up. It shows that the access are matched and the third I/O is matched, but the first two is not matched. From the tooltip, you can see that the vendor product information of the two devices are different. You can show their vendor product information by checking this checkbox. You can match them manually or automatically. For example, you can select the first project device and move it down so the first two are matched. You can also use the auto matching function. Let me roll it back. Click OK to auto match, so it automatically reorder the project I/O to match the found I/O. Then just click Finish to go back to the main window. Another situation is that you expect there will be more devices connected, but currently you only got like 1 access and 3 I/Os on hand. In this situation, you might want to create simulated access and I/O devices. The configuration tool allows you to create simulated devices for specific models. Just right-click the access node and you can select Add Access or Add Access from Database. For Add Access, you add an default access, but if you want to add an access for a specific model, you add from database. This dialog lists all the access in your ESI database. For example, I want to add Yaskawa's device SGD7S. It's the same for I/O device. You can add I/O or add I/O from database. Let's go back to connection settings. We first disconnect the EtherCAT connection in order to modify the connection parameters. In the devices settings area, we can configure required access to 2. This means that if the E-CAT component detects less than 2 accesses, it will create simulated access to match the required access count. Let's reconnect. And you can see that 1 simulated access was created. And these simulated access have the same identification information as the real SGD7S device. This is the first scenario. Use the configuration tool to connect to device to monitor and control them actively. The second scenario is that you have your own application to connect and control the devices and use the configuration tool to monitor and configure while your application is running. Let's demo this scenario. Let's first close the configuration tool, disconnect the E-CAT connection, then run our own application. I run the demo application here to create the connection and control the devices. Then I start the configuration tool while my app is running. You can see that the connection has been already connected. I will need to connect to the main device to monitor the SubDevice connected. Okay, it shows a message that the EtherCAT connection already exists and may be controlled by other applications. We click OK and we can see the connection parameter used by my demo application, and we can see the status of the SubDevice here, and we can monitor their input-output signal change, and for the I/O we can also see their output change here and monitor their parameter here. So the configuration tool becomes useful when you develop your own applications. It helps you debug the issue you encounter. The next scenario is multiple main devices scenario. You can see there are two EtherCAT main device instances here. You can configure multiple EtherCAT main device instances from the settings tool or EtherCAT configuration API. You can use the configuration tool to monitor and control these instances one by one, or open two configuration tools to control them at the same time. Let's start the EtherCAT configuration tool. When multiple instances have been configured, there will be additional instance text box here. You can enter the instance number you want to control, for example instance 0, and click OK. Okay, so I can monitor and control instance 0. To control instance 1, I can disconnect the main device connection here and reconnect the tool to instance 1, or I can just open another configuration tool and connect to instance 1. So now I have two configuration tool instances. One is for instance 0, another is for instance 1. The last scenario is offline edit. Previously, we always connect to an E-CAT main device when we use the configuration tool, but this action requires the subsystem, the NL2, and the E-CAT instance to be started. It will take some time. If you want to view and edit a project quickly, we can use the offline function. Let's go to the configuration tool and select work disconnected. When we select work disconnected, we can directly open or create any project for viewing and editing. So that's the three scenarios I want to share. Please check our documentation for complete function description. And if you have any suggestions for the tool, please let me know. Thank you for your time.